So, Gavin, would you like to start first for the architecture team?
Yeah, I can give a little quick summary. First, I'll just say, like, I know our coordination has been great the last week or 2 weeks. So we gotta kind of get it together for this presentation. But yeah, like Max said, we can do that. We have been meeting with Amy weekly. Thanks to Hayden for doing the last one with Amy and for updating the plans each time. So it seems like now we have a pretty final plan, which Hayden's posted, and I've also made it into a Rhino model, and I've started doing some simulations on it. I'm still kind of working on the software, but it allows us, this Climate Studio software in Rhino allows us to do a whole bunch of different simulations. So radiation, which is good for calculating how much the solar panels can produce. It can do kind of daylighting, and it can even do thermal stuff as well. So I think that is probably the easiest way for us to get those types of results for our presentation. Yeah, I think the thing we haven't done enough of is selecting the final materials for doing the material analysis and stuff like that. So that is the thing we need to work on. You have anything to add, Hayden? No? You there, Hayden?
Yes. So I think as Gavin said, the layout is more or less finalized. I think if you look over the the layout that I just posted on Miro board, or maybe I can just screen share to get a better focus. So as we updated so far is the crawl space here, and we also kind of targeted where are the modules would be, which are the brown areas. And then the only kind of change that kind of related to the roof is several areas that are right on top of the modules won't be staying as the same roof level as we used to propose, because Amy kind of mentioned that putting let's say putting an additional floor, a ceiling level on top of it, is kind of excessive kind of practice. So she recommended us just to leave the ceiling panel of the module as a part of the roof, and then you can see there would be it would be replaced by the a parapet to wrap around the perimeter of the roof, but leaving kind of around 1 foot deeper. But I think at the same time this could be also kind of beneficial, just to demarcate or kind of prioritize where the drainage areas would be. For example, for the top roof floor, these 4 areas would be where the levels is slightly lower than the general roof space here. So let's say these 4 areas could be the drainage zones, to put the drainage point, which can also connect with the already areas with utilities, to kind of connect vertically all the way down, which also kind of happened here. And the only 2 that does not have a level change is these 2 units above, because it's located up for the flat roof kind of access circulation. So I just keep it untouched. And she also kind of like just a kind like a minor reminder, like the crawl space, like the depth of crawl space doesn't have to be like a 4 foot depth. So we just kind of like reduce it a little bit to 2 feet, and then yeah, so not much change in overall. And yeah, there's also like a more detailed layout of how each module is kind of like formulated. So I guess would be great if like I don't know if like we need such level of detail, but like yeah, if like the materials or like the selection of glass or doors or whatsoever are kind of like finalized, then we can like input like more details for that, just in case we need for any kind of like calculation or estimation for anything we need. Yeah, so
Hayden, can you hear me?
yes.
Cool. So just something that I wanted to touch on, because I know you had brought it up last week. Get an idea of where that partition should go between the laundry room and the storage room.
Yes.
So just as like a quick kind of update from engineering B, I'm starting to I got a pretty decent list of all the appliances that we'll be using. And I'm working on a calculation software to get an idea of the sizing of the geothermal heat pump that we're going to use for the HVAC. That partition. So also kind of to add on to that, got an idea of how many washers and washer dryer combos that we should go with. They said that you only need I think that we should go with for 12 units. 3 washer dryer combinations would be sufficient, and they'd be stacked on top of each other. So essentially what we want to do is maximize the space in that storage room that would likely house the geothermal heat pump system, the electric water heater system that's actually going to be working in tandem with it, as well as potentially have some of the bus bar electrical circuit stuff that's going to be going to the rest of the rooms, and the some of the low voltage fire safety stuff, which a lot of that is kind of just attaching to a wall. So I'm confident that we'll have enough space for it. But I think that partition that's in between the laundry room and the storage room should be moved somewhere over to the left that you think is the appropriate sizing for 3 washer dry units to be kind of sitting alongside of each other.
Yeah, sure.
They're a total of, they're 3 feet wide. So, and I'd imagine maybe we're saying a couple of inches of space in between them or something like that. So, a minimum of 10 excuse me, a minimum of 10 feet in kind of width, maybe plus with a little bit of extra space or something like that. So if we can move that partition over somewhere around there, maybe if we can.
I think we can refer to the grid line. So I guess this square was pretty much what we need for the dryer, washer.
I think so too. I think having the washer dryer space have just be that kind of left unit would be perfect, and that would give us plenty of room for the storage for those other systems that need to go in there.
Yes, but so just one concern about the utilities you just mentioned, because it contains water services and the electrical services. So I'm not sure if they should really put right next to the other. And so do you have any thoughts about that?
Yeah, so I hear you. So I'm definitely gonna confirm that you can have so how it works is you have power that comes in from a utility. It goes into some sort of step down transformer, which brings the voltage down to something usable for your your residential applications.
Yes.
And that's really, if you've seen in like any room, like any electrical room where there's like kind of like a big circuit panel where like you can open it up and like flick on different circuits. It would be something like that. And most times that's in a storage room that you might find like the furnace for like heating the water, or you might find like some of like the mechanical components for like the HVAC system. I'm gonna confirm that those can be in the same room, but I'm like pretty sure that they can. It should be relatively like safe. This like HVAC system and the water heater, like, you know, they are supposed to be like very reliable, sort of like systems. And but yeah, like I'm gonna go ahead and confirm later today that like those things can actually go in the same room. But yeah, so I'll check in on that. But I'm pretty confident that we'll be good to go with that.
Okay, so like these areas here should be like all the where the water utilities would fit, like with the heat, the geothermal pumps and then everything. And I
Yeah.
guess like the circuit, like the board that attached
The
on
board
the
could also go in the laundry room too as well. Yeah,
yeah, I think yeah, somewhere like here would be good, like, and then
exactly.
facing, yeah, I guess something like that would make sense.
Yeah, exactly. That's likely what it's gonna look like.
Okay, sure, we can update for that.
Yeah, and I'm still working. I have the software that I'm going to be using, that's also kind of similar to like what Gavin was talking about, where like, and Jared's also going to touch on this for like his first score rating. But we just need a pretty comprehensive list of like materials that we're going to be using for the house, for the building envelope, and
Yeah.
and some of the wall spaces and stuff, just because those are things that go into the calculations for like how much heating and cooling you need, which would be ultimately how I can like size the geothermal heat pump that we're going to be like implementing into the system.
Which
Um,
software did you decide on?
Say that again.
Which software did you decide on using?
It's the ACCA, which stands for some sort of construction thing, but it's ACC Manual J is like the software that's like lets you calculate like loads for like heating and cooling spaces. But we could probably, like, you know, that could also just be like work in conjunction with like the software that you're using in Rhino, if you're able to get those similar numbers. But we can, I think that, and this is again something that I wanted to bring up with that me and Jared were talking about. Like, I think we should find a meeting time where like we sit down. Maybe it's next GM, or maybe it's sometime next week, where like we sit down with people from engineering A, engineering B, and the architecture team, and like work through that software and say like, hey, these are the numbers that we need. Like, do you have them? If not, like, can we try and get those numbers so that we can like run these simulations and calculations, if that works for you guys. But maybe that's something that we talk about at the end of the meeting.
That sounds like the sooner the better on that one.
Cool. Okay.
Yes.
Yeah, I just wanted to bring up that partition for you guys while you guys are presenting your stuff. But if there's anything else that the architecture team had, by all means, you guys can keep going.
Yeah, so I think that's more or less the update that we've got. So, and I don't think like the design partner also have like further comments, more or less, about like how our design is going to work on so far. So yeah, I think yeah, we definitely would switch the focus into more of like searching the appropriate materials, or like external, internal materials for the calculations needed. So
Yeah, I think the architecture team needs to actually get together and select those final materials. that sound good?
Yeah.
Yeah, that sounds good.
I can show a little bit of what the simulation produces. If I can share the screen, just for reference. Ends up looking like this. There's like, this is actually just for daylight autonomy, but it shows like, you basically place these sensors like in your model, and then you run a simulation, and it shows you like where there's daylight and where there isn't. And they have like a similar thing for like solar radiation, and I think for thermal, although I haven't started with that, but like this is one for the solar panels. Unfortunately, the output of this is like an Excel sheet with like the amount of actual like exposure or solar radiation on each of the surfaces, but I should be able to get the numbers from that. Yeah, that is it. Do any of the engineering teams have things to present? Jared or Sterling?
That software works good. Did you, sorry, I might have missed it. Did you say that you guys were finished presenting and one of us should go?
Yeah, you guys have something to present.
Cool. Jared, do you want to, would you mind sharing the Google Doc, our working doc from Wednesday?
Yeah, give me a moment while I put that together.
Yeah, so just from engineering B, we've been working pretty extensively on figuring out like what codes and what requirements we're actually supposed to follow being in California. It was a little bit of a wild goose chase, but we've kind of narrowed it down. Let's see, if you wouldn't, okay, so first talking about the geothermal, just a little bit more. So one of like the more innovative ways of approaching or of achieving a zero energy building is, rather than utilizing an air-to-air heat pump, which is like that ductless mini split heat pump system that I was kind of talking about like earlier in our kind of design process. The problem with that is that there's nothing really renewable about it, and that in order to operate the heat pump, we're going to be relying solely on the electricity that we're sourcing offsite, or the renewable energy that we're getting on site. So what this geothermal system that I'm proposing to implement into the design would essentially utilize the consistency and temperature about like 6 to 10 feet below the Earth's surface, and use that as either your hot or cold source in the heat exchange process. The idea is that like when you're heating a room, no matter how cold it is, how a heat pump works is that it has an outdoor unit and an indoor unit. The outdoor unit pulls hot air pulls heat from the air, no matter how cold it is, and actually funnels that inside to be kind of blown over the air that's inside of your space. Similarly, to cool a room, you're not blowing cold air in, you're actually extracting the heat from inside to sort of eject it outside. And so just basically what geothermal does is we're going to have a more renewable system that's kind of like operating on its own. We have like essentially an infinite supply of either a hot or a cold source beneath the ground that's gonna optimize the efficiency of the system. I'm working on the sizing. It's like basically these units that almost look like a fridge, maybe like a little bigger, and actually just like work and use water piping that we're gonna have to actually put below the crawl space in the design, or at least like propose that sort of like design goal of how it works is, so there's going to be like basically a bunch of horizontal piping that runs through to facilitate this like heat exchange process. Don't worry too much about, you guys are working on your own trades and stuff, so don't worry too much about like the actual like physics of it. But yeah, based on the heating and cooling like loads that our building requires, I'm going to be able to get an idea of what size of system that we're going to want to use. And additionally, these systems can actually be used based on like how much heat, like heat that normally is wasted in the heat pump process can actually be used to use in conjunction with a water heater, based if you like find the right models. So to like also further optimize the efficiency of our water heater, to get hot water, like we're also going to be, I'm proposing to use that geothermal heat pump system in conjunction with an electric water heater.
Sterling, you're muted.
Oh, sorry. Can you hear me now?
Yep.
Cool. Okay. So yeah, that's kind of the overall like premise of the geothermal stuff. Couple of concerns is the ability for the geothermal system to sort of like individually extend to multiple different rooms. Some of the ones that I found have only been able to go up to 6 spaces. So that's like, I'm not sure if we're gonna have to like look into just extending the sizing of the unit. Like maybe they have more industrial grade ones for larger buildings, or maybe even looking into like 2 units or something like that. But that's gonna kind of just come with like once we determine the heating and cooling load demand. Ventilation, we might need to look into exhaust fans for the bathrooms. I think there might be some requirements on like the ventilation that you have to have for bathrooms. There is the question of cost, but I'm not at my computer now, but I can show anyone who's like concerned that like over your like conventional efficient furnace and air conditioning unit, over time this is actually far more like a much better investment to look into geothermal. Also from like the engineering A team or the architecture team, I'm gonna need like some information on like the type of soil or bedrock that we're working with, because that goes into the heat exchange calculations for the geothermal stuff. I had watched a heat spring that kind of like helps you with how you're actually going to get those loads, and using like a different software to take those load requirements that way we'll hopefully get from like Gavin software and actually determine like the sizing of the geothermal heat pump. Let's see. So that's going to tie in with, we'll finally be able to get like an EUI calculation. That's going to come with some of the appliances that are down lower. If you scroll down a little bit, yeah. So the purple, just scroll up a tiny bit, a little bit more to show the writing at the top. Perfect. Yeah. So these are some of the efficiency measures that just like we're mentioning. So as I mentioned, we got the geothermal heat pump with HVAC combined with the hot water to make those 2 systems work in conjunction with each other, where the waste of one is actually going to be used by the other to like increase the efficiency of our hot water access. Gray water remediation is something that I wanted to talk about, where we can use there's like filtration systems for that's taking water from our sinks and our showers, and they can undergo a relatively simple filtration process so they can actually be used for toilet fixtures. I'm still looking into like what type of models are out there and how much room we might need for that, and like where they go. So that might be also something that we might be looking into it going in that same storage room, Hayden. But I just need to I'm going to figure out like the sizing for it. Yeah, LLC is luminaire something level control, which is like, it's basically like smart lighting level control, where yeah, it's just like a smart system. I don't know if we necessarily need to dive too deep into, like, they use all sorts of like Wi-Fi and phones and stuff to like control your lighting. It might be a little bit too like, I don't know. I just don't think it is necessarily what we like necessarily need to achieve. It might be a little bit unnecessary for this, but we're definitely, I'm working on getting some of the LEDs, the idea of like our lighting requirements. Gavin, I think that might play into some of the daylighting stuff that we like, the daylighting information that we have might be useful to determine how much lighting that we'll actually need.
Yeah, I think we can get like the daylighting, the average daylighting on a specific day, and then get the extra that needs to be provided that's not daylight. So that would basically be what you plug in for the lighting load.
Cool. And then, yeah, so we need to figure out like how much lighting is required for like a given area, and that's going to determine like the type of fixtures that we use. Okay, what else is there on this guy? Okay. Jared, if just so I don't forget, if you want to bring, maybe if you're going to show the revision 7 document and talk about that exhibit 1 with like the other like sort of requirements for like the building envelope, you could share that like after I finish running through the rest of the stuff here. Is that cool with you? Okay,
Yeah.
sweet. Just don't want to make sure that we touch on that. Okay. So yeah, so I've got an Excel sheet for the load calculations. This first table here is the washer, dryer, the dishwasher. Working on the sizing of the refrigerator. I'm going to use those module dimensions that you guys have to get an idea of how much space we have like for the refrigerator. Most dishwashers are like pretty conventional, and then how much room we have for like this like a stovetop oven kind of situation. Yeah, so the electric heat pump and water heater are kind of like and the ground source heat pump are just like TBD right now because we need to know the sizing requirements first. All right.
One note on the ground source heat pump. I think there's 2 types of systems for that. There's like kind of vertical shafts, and there's more horizontal systems. I know that the vertical ones are generally more expensive, but they use less space, whereas horizontal is shallower, so cheaper excavation, but you need the horizontal space.
Right.
So I assume this would probably be below the parking lot.
Right. Yeah. So, and I'm thinking that we would do the horizontal one, not do the bore down. Just because we have a bit of a larger area. So I think that we'll yeah, I think it's just more feasible, and you can actually do like different type of coiling configurations where you like almost like slinky the coils so that you can get like more heat extracted or more cold like cooling extraction out of like like a given area basically.
Right,
yeah, so it's really the and obviously we're going to utilize a closed loop system. Like an open loop system you like also uses like groundwater, which gets pretty frisky and crazy. Right there you can see the coiling stuff to the left a little bit. But yeah, so thank you for bringing that up. But yeah, we'll definitely work with like a horizontal slinky like system. Jared, would you mind going back to the working doc real quick? Got just a couple more things on my end. Yeah, so then the EPA Watersense program is basically like the Energy Star equivalent of like appliances that have water running through them. So that's going to be our toilets, our shower heads, sinks, bathroom sinks, kitchen sinks. For those, it really just comes down to like low flow fixtures. This is also going to be good in getting the idea of how much water we're going to be requiring based on those like the fixture count that I'll also pull from the plans. Yeah, and then just a little bit more down the lighting stuff. Yeah, so this is just like, again, the lighting is kind of TBD because just need to narrow down like exactly how much lighting we need for each area. But that's more information that I'll find. But yeah, just from like my end, we're starting to get numbers, which is exciting. It's been like a bit of a wild goose chase from me and Jared on trying to figure out like what we actually need, like what building codes and stuff we're supposed to follow. But progress is being made. So, and yeah, that's all on my end. If Jared, you wanna take over?
Yeah, definitely. I totally second what Sterling just mentioned. So yeah, all the links and stuff, we have, if you're curious, the geothermal, this is the Department of Energy, like kind of gives like an overview of it, kind of the pluses and minuses with each one. We definitely made a point in our previous meeting to kind of go and compare kind of the air-to-air electric heat pump versus geothermal, like ground source versus air, right? I know definitely when you look at California energy efficiency standards and the stuff that's, looking to be implemented, they make a point of trying to encourage more adoption of like electric heat pump systems, basically to decrease your, natural gas end uses using fossil fuels. Geothermal also does that as well. And, we think it's more of a kind of an innovative kind of approach to doing our HVAC as well as, water heating as well. So we felt that it was worth definitely looking into. And we've definitely seen like the benefits proposed for it. Like it was previously mentioned, one of the issues that we thought about was cost for implementing. I believe there might be like some type of, I don't know if it's like a tax incentive or something like that, or tax credit. We would have to look further into that, but in terms of like, the cost of these systems, that's something that we're definitely going to take into consideration when finalizing the HVAC system. But yeah, going on to what I had found out just recently. So I put a message on this in the Discord in the Engineering A channel, but if you go to the solar decathlon, I'll just run through it. We didn't notice personally up until last week. So maybe you guys already knew about this, already figured it out. But for instance, if you go on these, go here and you go to the project requirements, and basically, well, under divisions for our like attached housing, there's a link to the Department of Energy Zero Energy, Ready Home National Program, right? So if you click that and open it, it kind of gives us, those requirements for, how to be zero energy ready, right? And they specify that for new construction, we need to meet these requirements. So these requirements kind of detail specific ways you can go about being zero energy ready, certain calculations and metrics that help you with that. They define, certain areas and mandatory requirements for each of them. So like the envelope, duct system, lighting, indoor air quality, etc. Right? And they give like a lot of detail and, some like, I guess more high level in terms of like what's required. And then they have footnotes accompanying them, kind of going into the details. What we were unaware of when we first saw this was that it mentions that for California, there are like regional requirements here. So it kind of, it's basically like, hey, like, this document kind of just is all other states except California. So when you actually go to the, if you were to look up like DOE Zero Energy Ready Homes, right? And you look at those program requirements, if you scroll down to the program requirements, the revision 07, what you just saw, is linked here. So this PDF is basically the same link, right, as to what I showed you. But if you scroll down to where it says like state requirements, state specific ones, California has its own, right? So if you were to click that and you open this PDF, there's California specific program requirements, right? If I had to guess, I would assume that it's because, you know, California, in terms of like their, you know, implementations on energy efficiency might be a little bit more stringent or may exceed the national ones in some extent. So they have kind of like their own defined requirements for this program. There's one specific way, well, not necessarily one specific way, but there's one kind of path presented to us here, and that's, you know, here in the performance path. And, you know, I'm not going to go through like all this, I'm not going to bore you with the details, but I definitely would recommend for engineering A and architecture team as well, mainly engineering A, in terms of, you know, because our engineering design needs to abide by these requirements, specifically on page 2, where it talks about the envelope of the building. It gives kind of footnotes regarding the fenestration, you know, the windows and everything, ceiling, wall, floor, slab, insulation, and things of that nature, right? And then obviously like these other areas, you know, we in engineering B are gonna like look into to make sure that we abide by that. One example of this that Sterling showed was for the lighting and appliances, for instance. You know, 90% of those lighting fixtures need to be Energy Star qualified, right? And I know Sterling was looking into appliances that fit that mold, right? We still need to, you know, do some more research into clarifying like how much these appliances would be to each room, which is great that we have that in the drawings that Hayden put together that kind of have different types of rooms, right? And if we're able to count like, you know, how many of these types are in our design, you know, that can definitely get us like hard numbers in terms of the appliances that we need. And that could, I hope, help us in determining like the energy consumption through lighting and plug loads and things of that nature. So yeah, I would definitely recommend engineering A. If you, assuming if you have already done this, that's excellent, that's great. We just found this out just recently, you know, because California has specific ones, but yeah, definitely. So specifically on the envelope side for engineering A, and you can see like the footnotes that they have here, 10, 11, 12, 13. If you scroll down, it's pretty much, you know, you can find those here. You know, these talk about window specs and what have you, fenestration, etc., things like that. So that's pretty much what I wanted to share on my end. And this is kind of like what we're going to use to make sure that our engineering designs abide by these requirements, essentially.
Just to chime in real quick, thank you, by the way, Jared. So yeah, he found that crucial document. And then there's also like two ways that we like meet the energy requirements that are like different from the HERS index, that are like in those documents. Jared and I are gonna figure out what they mean. One of them's like compliance total. Compliance total, and then the other one's delta DED design or some delta EDR. That's what it is. Again, no idea what those mean right now, but they will be determined. So yeah, but awesome stuff.
Yeah, that's definitely one of those things. If you look on the national requirements, they have specific ways you can go about meeting their requirements. They call it a prescriptive path and a performance path. And they utilize, you know, the HERS index, for instance, right? In terms of, you know, establishing some type of metric to see if your design meets up with their requirements. For California specific ones, they didn't really mention HERS scores here, only a little bit towards the end, but this step would be more along the lines of if you actually had a design you were going to build and you wanted inspectors to come and chime in, they would utilize a HERS score, right? But for here, in terms of just our design process, they give 2 different types of software to kind of, you know, go about doing it, like Sterling mentioned. or two different metrics that utilize, software. There are links to, approved software and stuff like that, so we can get our hands on it. But essentially, these are like the two ways we can identify whether or not we've met their kind of requirements or their target, using a compliance total within this range, or what they call a Delta Energy Design Rating that's greater than 4. Both using California Energy Commission approved software and things like that. And yeah, they definitely make a point of excluding on-site power generation as a part of this calculation. They kind of want, I guess, more of the bare bones of like your energy consumption from the building. So although we definitely are going to implement solar and we want it to be used for us to satisfy, efficiency standards and actually have on-site generation so that we can actually be zero, these calculations make a point of kind of excluding that. So it's not necessarily required that we have that number, although with the updated design, I'm going to be updating the mural board for the solar PV. But Gavin already had like the software that uses like the most recent model. So that kind of factors in the area and everything. The calculation is just kind of like putting the wattage in a nice neat package. But you can expect that to be updated soon in congruence with the plans. But yeah, long story short, we're gonna be working on trying to, look at the software that's available and try to abide by this kind of performance path to make sure that our building meets the requirements. Is there anything else that needs to be said, or is that pretty much all that we have, Sterling? All right, I'm going to take that as a yes. So
Yeah, sorry, I just got dropped from the Zoom, but yeah, I was following.
so Hayden said there's nothing to update on her side. So if engineering A has any updates that they want to share, feel free to do so. Otherwise, I think Max can, I guess, wrap up the meeting.
Yeah, a little update from engineering team A is that we started looking at the document, and I think Ken has started on the calculations on installation in the envelope. And we were also looking at the fire rated requirements, because it's one of the the fire rated requirement of the IBC, and this is something that we'll continue to work on. And also, I think last week I mentioned about doing a little markup for Hayden on the foundation, and for some reason I never sent the markup to you, but we can take a quick look right now if you would like.
Okay, and sorry, but where did you upload
I
the?
have not uploaded.
Okay, yeah, yeah. Just you can
I
just
uploaded.
okay. Is it
I have not uploaded yet.
Okay, never mind. Just once you upload it, you find maybe you can like tell us on Discord.
Right. I just don't know like where to put it. Like would be the best. Maybe like
Oh,
create a markup folder.
you can
in
either
the drive.
put onto the Google Drive or even on Miro board. Yeah, just tell us when you did it.
Sounds good.
Thanks.
Oh, and also I'll make a point of mentioning this real quick. The previous faculty advisor for like previous solar decathlons, Professor Pilon, I'm actually in his class right now. It's a mechanical engineering class on like energy and the environment. And I have, been able to like talk with him and stuff like that. So if anyone, that's an additional resource that is available to us for kind of like, some like maybe technical in nature advice or what have you, for like, building materials, for instance, or something like that. He mentioned that he was knowledgeable on that front. So if, engineering A or architecture team or anyone in engineering B wants to maybe, give me some questions to ask him, I could ask him, next week we're going to be in person, so I'll be able to talk with him, after class or something like that. So he is, an additional resource for us in terms of like technical questions and what have you. So I just wanted to make that known. If you have any questions that you think would be fitting for him to answer, definitely let me know. And who knows, maybe we could arrange for kind of like a little meeting or something like that if time permits, or if you can just submit me questions to give to him, and then I can get answers to you when possible.
Sounds good. And also, I think you mentioned about the soil, assessing the soil for the thermal heater, right? Jared or Sterling?
Yeah. What about the geothermal heat pump?
Yeah, so for that so what do you need to know about the soil?
Yeah, so there's like
around?
I just need to know what soil it is, like what's like underneath the building, basically.
Right, the soil type.
Yeah, exactly.
Okay.
And the
Yeah.
soil type will help me determine it's just like it's for like different thermal conductivity of like for like the pipes and like their interaction with the soil, and like that helps determine like how much like how readily we can like either let off or take in heat.
All right, we'll provide that too.
Cool. Yeah, thank you.
And I have a question about the geothermal pump. So is the coiled like thing, so is it planned to be built under the parking lot?
I haven't exactly, I think it's gonna have to be determined based on how much coil we need. So I would imagine, because I mean, it's to be determined, I would say, is a short answer to that.
Okay.
But
No problem.
likely underneath, like either like underneath the parking lot / like kind of around the perimeter of the like the building. The good thing is it would be like below like any crawl spaces or anything like that. Like it would have to be dug down a little bit deeper. And I think that the realistic like implications of that, like actually building that might be a little bit difficult, but like, for the purpose of like this design project, like I think like saying that we have like this amount of area allocated for like coiling and stuff, like we wouldn't need to like dive into the weeds of like, oh, it has to be built underneath like where our foundation starts and whatnot. So I think what's just going to be important is like how much area first, we'll need to use, and then from there, and then just kind of like go from there.
Sounds good. Thank you.
Yeah, of course.
Is there any more for anyone?
Yeah, just real quick, I wanted to, if there isn't anything from anyone else, update wise, just wanted to see if there's like a time next week where, I mean, if we're comfortable with like meeting in person, you know, a time next week that we could all meet in the space and like hammer out some of those numbers, and like Jared can show, he needs a bunch of numbers for like the HERS index, and those are the same things that are going to be needed for like determining like our heating and load, or I'm sorry, our heating and cooling load stuff. So if like maybe Max, you would be willing to send out like a win to me, or if we want to just like figure it out now, like a time like maybe Wednesday night or something, like where we could all meet up and like try and just like organize all the numbers that we need to get so that we could have them like before next weekend, and hopefully we can like get those values in before like we, you know, try and hammer out the presentation or something like that. Or getting stuff earlier than that. I don't know.
Yeah.
We should try and figure
oh,
it out now.
go for
I
it.
think. You said Wednesday.
Yeah, Wednesday generally works for Jared and I. We usually have our sub team meeting, but like it can literally be like our sub team meeting, where you guys just like come at 6, if that works with you guys. Like we can do it like at the builders, or at the HQ in Bolter. I'd be down for that, because like that's really like the numbers that we need for like our sub team meeting.
Yeah, I'm
Does
unfortunately
that
busy
time,
from 2 to 7 that day.
you're busy 6 to 7?
2 to 7, 2 p.m. to 7 p.m.
2 to 7. Okay.
We could do
Tuesday.
after 7.
Yeah, we could also start it at like 7:15 on Wednesday. Does that not work for anyone here right now?
Yeah, I mean, the room is already reserved for us, so don't worry about that. Yeah.
Cool.
Okay,
Yeah.
okay.
So I mean, if no one's got objections for 7, we can go ahead and move the engineering B sub team meeting to 7 on Wednesday, and it's really just going to be like, I'd imagine hopefully like Jared's laying down some of the numbers that he needs for the HERS score, and then I would love to see Gavin like just kind of be able to sit there like with you, and like look through like what the Rhino stuff is, or like what that modeling software is, and see if I can provide any intel. Oh, sweet.
Yeah, those are just a link to some of the tutorial videos for the software. So it shows.
Awesome.
like,
I'll definitely look at those before. Oh shoot, it's not letting me copy it.
Yeah, it just shows different metrics.
Oh, I think I got it. We're good. Yeah, so I'll definitely take a look at those before Wednesday and get an idea and see if there's like anything that I should like kind of bring to the table. But yeah, sweet.
Oh, yeah, I just also
Okay.
sent and
Sounds like a plan.
keep going.
Yeah, so just to confirm, like 7/7/7:15 start time for like engineering B sub team meeting, and hopefully we can get representatives from A and like the architecture team there.
Okay. Yeah, have you guys all received the new calendar invite?
Just did.
Great. Okay. Culture hall. 3, 2, 1. Awesome. Great. Yeah, actually, also like speaking of like in-person meetings for like the general. I mean, first of all, is there anything you guys want to add into this meeting? If not, I can just sort of announce, give like a final debriefing and announcement for what is to come. So, I mean, Oliver, can you stop sharing screen?
Sorry, what was that again?
Do you mind stop sharing screen? I'm just gonna give announcements right now.
Okay,